Hello and welcome. In this video series, I will be discussing the topic of metals and their extraction. The kind of things I'll be talking about are the reactivities of metals, as well as the process of redox, which stands for reduction and oxidation, to individual chemical processes. I'll talk about the industrial extraction of iron and aluminium, each which have their own extraction and separation process. I'll talk about electrolysis along with its electrode equations and therefore the uses of electrolysis. It's important to note this early on in the series that very few metals are found in nature on their own, purely separated from anything else. Most metals are found as metal ores, compounds in the Earth's crust which contain the metal you want to extract along with impurities. For example, probably one of the most commonly known metal ores is one called hematite, which is iron ore. The image on the left shows one particular reactivity series, with reactivity decreasing down the group, making potassium the most reactive metal and gold the least reactive. Although this particular trend you will not have to memorize, I will highly advise that you are familiar with it, as it will help make sense of future reactions we'll look at, such as displacement and competition. One particular trend in the differences in reactivities of metals is that the more reactive a metal is, the more stable of a compound it will form, and therefore the less reactive a metal is, the less stable the compound. You can think of this as if a metal is more eager to join with another atom, is less eager to let go of it. So the more stable a compound is means that it's harder to separate it, so you require a method of separation with a higher energy output. The most reactive metals, so in this reaction series will be above carbon, require a process we mentioned in the previous slide called electrolysis. The compounds that are formed in the middle, so this will be above copper, below carbon, so that's zinc, iron, tin and lead, are separated with a process of reduction via carbon monoxide, and as you'll see in the extraction of iron, carbon dioxide as well. And then the least reactive metals, which is copper and silver, following this reactivity series, not gold, require a more complex reaction pathway, so sometimes more than one process. This could be a combination of electrolysis and reduction, maybe something else as well. The reason gold isn't included is because gold is actually so unreactive, it is found in nature as just gold, not with anything else. The reactivity series can be proven by looking at how metals react with certain substances, one being water. So following the trend of the reactivity series, we can see that the first element up is potassium, which reacts with water very violently. So potassium is an alkaline metal, and they are infamous for how they react with water. Following this reactivity series, you have sodium, which is less reactive than potassium. It still reacts very quickly, but potassium reacts violently. It reacts much quicker. Another element is lithium, another alkali earth metal, which reacts still quickly with water, but not as quick as sodium. On the periodic table, it goes lithium, below lithium is sodium, below sodium is potassium. And finally, you have calcium, which is an alkali earth metal, which still reacts with water, just much more slowly. Another reaction which proves this reactivity series is how metals, more commonly transition metals as opposed to the alkali metals, and how they react with dilute acids. So whereas calcium reacts with water very slowly, calcium's reaction with dilute acid is actually very quick. Below that is magnesium, and now following this reactivity series, we see that zinc reacts more slowly than magnesium, iron even more so, copper even more so, silver hardly reacts, and gold, no reaction, completely stagnant. When a metal reacts with an acid, the reactivity can be shown by the rate of the formation of hydrogen bubbles, as when a metal will react with a dilute acid, hydrogen gas is given off. This has been a short video, just briefly discussing the reactivity trends of different metals. I hope you enjoyed.